Hello, everyone. Part 2 for week 11, visitor pattern. I don't see any new question from Google Doc since yesterday. I just checked it right before the session. So if do you have any questions about visitor pattern? Well, any previous lecture will be okay too. This week is only about visitor, so it's like a shorter lecture than usual. So we answered quite many of them already yesterday, but if you got new questions, I'll be willing to answer. All right, I'll pause a bit and then just to see if you got any questions. Yeah, put on the chat or you can speak up. Okay, one question from Nina. Let's take a look. Observer design pattern and event-driven design were solutions for distributed systems. Yes, especially you got clients and also supplier, right? Clients and server, basically. And observer is more for one subject and multiple observers. And the event-driven is actually more general, many to many. Can they be suitable for non-distributed system? So here, when we talk about distributed system, right? I think, okay. So don't really be so restricted that distributed really mean geographically distributed. Okay, so I think I can see what you're coming from. Okay, so Nina's question was, whenever we talk about observer, or we can't talk about event-driven design. So these two are actually both for distributed system. And a little bit more specifically, for observer is really one-to-many, right? So one server and multiple clients. One-to-many, right? And event-driven design is many-to-many. Okay, so now for distributed system, I would say, if you talk about the more restricted sense, we talk about the server and clients are geographically distributed. Okay, so geographically distributed clients and servers. So certainly this is one applicable scenario you can use it. However, I would say number two, it can be a little bit more general. As long as you can modularize your solution into maybe different parts. And one part is really about some subjects, which is observed by the other module, which will be observer. I think as long as you get that kind of a distinction, it will be applicable for the distributed system, right? For the two solution over here. So number two, as long as you can modularize your solution, well, design solution to be more specific, right? Your design solution into basically, so one part would be just about the subjects, right? So I'm just being a little bit more, just use the term, borrow the term from the observer pattern. So if you got subjects and also you got basically observers, as long as you got A and B over here, they don't really have to be geographically distributed. You can still apply that. So you can think about distributed systems, a very general idea. It's not just for physical distribution, but also if they are still within the same system or in the same machine, you can still use this pattern over here for solving the problem. All right. So Nina, does that answer your question?
So I actually have a follow-up question.
Go ahead.
So if it's on the same machine, at what point would you draw the line and say, okay, now I should probably use the observer pattern rather than just access each attribute individually?
You're saying that if they are on the same machine, so when would you actually use observer, right? So I would say it's really about, for example, as long as you actually have the following. Okay, let me be a little bit, I think I just need to be more elaborate on number two over here. So let's say for number two here, as long as when you try to design your solution, you got one module over here, and you got another module over here. Let's say, for example, of course, in the context of OO, object-oriented programming, it would be classes. But let's say you got two modules over here. As long as you got one module over here, module 1 and module 2, and module 1 over here simply just got the various data which might be constant, maybe subject to constant updates. So you got various data over here. So these are simply just data under constant updates. And then you actually got some conceptual dependency over here. Okay, you got some dependency, which means over here, you can think about module number 2, the client supplier, right? So you can think about this is actually maybe some, I'll just say subjects over here. Basically, module number 2, in order for module number 2 to actually work for its internal computation, in that case, you will have to monitor whatever changes that's really happening in module 1. Okay, so I'll put it here. So you can say, in order for computation in module number 2 to work, you need to get in sync with module 1. I would say in general, if you actually can sense such dependency between the two modules, I think they will be good candidates for module 1 and module 2. However, I'm not really suggesting that every client-supply relation can be turned into observer pattern or event-driven design. That's not what I'm trying to say. What I'm trying to say is this special kind of a client-supply relation, in which case one module has to closely monitor another module over here. However, if you simply, for example, I think, let's say without the observer pattern, what you would do is in this module here, you have to be very proactive about whatever changes that might be happening in another module. So you have to keep calling the updates into here, right? So in that case, the good design pattern will be we try to do the reverse way. We want the party over here that's subject to changes. Whenever there's any change happens, we know there will be a list of instances of M2 that depends on the changes. In that case, you will simply just notify in this direction over here, right? So that's kind of the observer we talk about, right? So Nina, does it help? Or you got any more questions? Okay, very good. All right, but that's a good question. I think again, for every design pattern, you will have to know when to use which. Yeah. All right, guys. I will just wait to see if you got any more. Okay.
I have a question.
Yeah, for sure, Laura. Go ahead.
Yeah. In week 10, you talked about how the classes subcontract, they take their contracts from their parents.
Mm-hmm.
Okay. So I was thinking when you said the expectation of the client, I was thinking if the client had the static type to be the same as the dynamic type, would it still run the same way? Would it still have to check?
Okay. It would be the same. Yeah. Okay, I see what you mean. So I think maybe this briefly mentioned, also it was discussed last time, but I wouldn't mind repeating since you fellow students don't have any new questions for now. So basically Nora's question was this. Let's say we got, let me set it up. Let's say we got our class. Let's say over here, this is the parents. And then over here, we got the child. Okay, let's say we just got one routine over here. And then we simply got require. And also we have ensure, right? Precondition, postcondition. Let's say require just alpha and beta. Let's just use the same symbol, as you use in the lecture, just to be consistent. And then also we just simply redefine the R. Okay, you can think about R is already implemented, and we just redefine that. And then here in the child class, it will be require else, and also ensure then. And then in this case, I'm going to put gamma and also delta. And then, of course, we're assuming that we actually got the inheritance relation between the two. So I will simply put something like this, right? Just an inheritance relation. Okay. So what you're asking was this. Let's say this. If I got a fragment of code from the clients, if I simply put, let's say, objects over here, and then let me try the various possibility. Maybe let's try the first one. If I simply say object is of type parents, all right, and then let's see how we initialize that. So now apparently we will know that at the runtime, the possible dynamic types can be any class that's a descendant of the parents, including itself. So we got two possibilities, either parents or child. Let's just do one by one. Let's say if I do creates over here, and then I will simply say objects. If I simply omit the curly brackets, it will be as if, right? It will be as if I simply just put parents over here, right? It will be as if, okay? Let's just keep that over there to remind you. Okay, so after this, let's say we simply try to call, let's say objects.routine. Let's say it's a command. Let's not worry about any parameter, just to without loss of the generality. All right, so here, what's going to happen here? Basically, exactly the contract that will be called at the runtime depends on the dynamic type. So now you can see the dynamic type. So now after this, dynamic type is simply just the parents. So now in this case, the precondition we're going to check at this point is going to be just alpha. And then the postcondition we'll check will just be beta. So we are also assuming that this is already the top of the inheritance hierarchy. In that case, there wouldn't be any further ancestor that's further up to accumulate any contract, just to make it simple. All right. So Nora, are you okay with the first case over here?
Yes.
Okay, first one is good. Okay, let me number that. Okay, this will be first one. Let's talk about the second one. The second one here, let me use a different color. For the second one, let me say I still use the same object over here. I just recreate it. So I will simply say creates. And then, so this time I just try another possible dynamic type, which would be, let's say, the child. Okay, and then also obj. Yeah, of course, I could have simply say obj.make, if you're wondering, of course. Yeah, let's assume we also got the constructor make, just to be standard. Okay, so after this, we know that after this line, the dynamic type will be the child. So now at the runtime, the contracts that will be checked depends on whatever that's being accumulated along the ancestor path. So now since the dynamic type is actually child over here, so that means we have to accumulate both alpha and beta accordingly to the precondition and postcondition. Okay, let's see how exactly that's going to happen. So now for number two, so we're going to say obj.r, right? And then before that and after that. So now for the precondition, it's going to be not just gamma, but also the alpha that we actually inherits. In that case, we're going to disjoin them together. So it's going to be alpha or gamma, right? And then for the post condition over here, we're going to get delta and also beta and conjoin them together. So it's going to be beta and delta. So Nora, is that okay for the second case?
Yeah.
Okay, so far okay, right? Okay, let me just do one more example, just one more. Basically, you can think about in total, there are simply just 3 cases, basically. Let me just put one more, okay? One more case, let me just use possibly maybe orange over here. Let me just put it here. Let's say objects number 2, okay? And then that's of type child. Okay, this one in some ways simple because what would be the possible dynamic types given this particular static type? Only child and its descendants. And now child itself is descendants, but and also we're assuming that there's no further down descendant classes just for simplicity, right? So now what we'll do is, let's see number 3. And then for number 3, we're just going to say creates, okay, we're going to say obj2.make. So what this will get is dynamic type is going to be just the child. So now it will be very similar to case number 2 then, very similar. Okay, so now if I say obj2 dot r, right, and then I'm going to say here, precondition and postcondition. So now the precondition is going to depend on the dynamic type, which is the child. So we're here. So now we're going to check both the alpha and also, both the gamma and also alpha. And then we're going to disjoin them. So it will be identical, alpha or gamma. And also for the postcondition, it's going to be delta, also combined with inherited beta. So it's going to be beta and also delta. You can see it's identical to this. So these are the three cases, basically. Are you okay with it?
Yeah, so my question is, when we talk about the expectations, we're not talking about the dynamic type, the static type expectation. You're talking about like
So basically, yeah, I see what you mean. So there are two aspects over here. So when you only talk about what's going to be checked at the runtime. So when you talk about runtime checks, number one, when you talk about runtime checks, in that case, of course, you have to look at the dynamic type. I would say consider. Consider the dynamic type, for sure. That's exactly what we're doing. For example, you can see here the dynamic type is actually child versus the dynamic type over here is the parent. So you can see what's really checked at the runtime might be different. So that's number one. I think for what you might be confused about is number two. And for number two, it's more about the design time analysis that we have to do about expectation. And the expectation we need to think about is over here at the design time. We want to make sure the precondition actually require less in the child class. And also the postcondition in the child class actually ensures more, right? For the rationale that we spoke about in the lecture. So now, so you can think about whenever we talk about expectation, you want to make sure when we actually want to check, when we want to argue that whether or not this particular precondition that's in the child class is actually reasonable, we want to make sure we don't create any shock, meaning that whatever that would be acceptable as the input condition, it should be considered as acceptable as well in the child class. That's why we say that it should be alpha implies gamma, right? So alpha over here in the parent class, if it is already satisfied, this one should be satisfied as well at the design time. That's how we analyze whether your design for the contrast is actually valid. And similarly, what about ensure more? We want to make sure if whatever you can guarantee in the child class, so that means it's also guaranteed by the parents, right? In the reverse way, right? That's also we spoke about intuitively. So that's why we say delta also implies beta. You want to make sure your child class can ensure at least those that's really ensured by the parents. Okay. So that's about the expectation. So don't really mix about what's really being checked at the runtime versus what you have to prove in order to judge if the design is actually valid. So, all right, does this make sense to you?
Yes.
Okay.
Perfect.
So I think that the main thing you were confused, I can see. When you talk about expectation, think about we have to use the expectation to judge whether or not a particular precondition, for example, is actually valid with respect to the precondition in the parents. You have to prove or disapprove this particular implication. And similarly, if you want to prove if you're given a postcondition in your child class is also valid with respect to the postcondition over here, you have to prove or disapprove this particular implication. That's one aspect. And then when we go to the runtime, we talk about just about exactly what will be checked, right? And one more thing for you to also refer back to the notes, maybe when you prepare for the exam, you can come back to me in the exam review session if necessary. We say that, okay, let me just write something for you. I think that's also mentioned in the lecture as well. Let's just talk about this particular case. Okay, let me just put it over here. Okay, let me just to say some follow-up discussion to this. Okay, let me put it here. Okay, so now we know that for example, let's consider one case of invalid. Invalid precondition would be, for example, let's say somehow this particular gamma is not really weaker than the alpha. That's the validity constraint. But let's say it turns out gamma is actually stronger than alpha over here. So that means the child precondition is stronger, and which means it's invalid. First of all, let's just consider what's going to happen. We know that for this particular invalid precondition at the design time, this is what you can judge, right? So this is invalid at the design time. Okay, and then let's go a little bit further. Let's say given this particular invalid design, what's going to happen at the runtime for that? At the runtime, what you're going to check if the dynamic type, let's say given that the dynamic type is actually the child. We know that we're going to check. The precondition is going to be basically like this case pretty much, right? The child class is the dynamic type. In that case, we're going to check alpha or gamma. Check alpha or gamma. And there is a little bit logic you can think about. When you want to check alpha or gamma, okay, let me just highlight the two things. At the runtime, we want to check alpha or gamma in disjunction. And we know already this is the case. Gamma is actually is like a stronger than alpha. So now let me have a little bit logical quiz for you if you like. What would this be equivalent to? If we say this is the case, and also we want to check this, what would that be equivalent to?
You mean which of the cases?
Okay, let me put it more. Okay. Let's say this is number 1. Okay, that's what we know from the design time. And this is what we're going to check at the runtime 1 and 2. We want to combine 1 and 2 together. If you combine 1 and 2 together, so let me write it down. If I know that gamma implies alpha, and then I want to check alpha or, oh, actually, you know what? It's better to write it this way. Let me write it a bit better. If I know that this is like a let's say that's my antecedents. This means alpha or gamma is equivalent to something. Okay, so this is my question for you. If I know that this is the case, so this will be equivalent to something. What would that be?
Gamma?
Are you sure? If you're sure, I'm going to write it down.
Just because alpha or gamma would equal not alpha or gamma, right?
Actually, gamma is actually stronger. They are not equivalent. So if you, actually what you said was right. Okay, I just want to make sure you're actually sure. Yeah. Think about what we're saying here. Gamma implies alpha. So you got gamma here, and then this is alpha, right? And then when you try to say, you want to disjoin them together. So actually, did you say gamma or alpha? Sorry, I forgot.
I said gamma.
Gamma, it's not gamma. Sorry about that. It should be alpha. The reason is, if you look at that over here, you can see when we say gamma implies alpha, it's going to be gamma is like a subset for alpha for their satisfying value set. And then when you say, I want to do a disjunction between alpha and gamma, I'm basically trying to union them together, right?
Yeah,
in that case, what we're doing is we're trying to union. So that would be alpha.
Yeah.
Okay, so what's my point? The reason I'm doing this a little bit logical reasoning over here is, I want to say after or. The precondition in the parent class matters the most. Even if your design over here is not really valid, but however, just because the way we check for precondition using disjunction we will still make sure it's logically equivalent to alpha. So that's the point I'm trying to make. So try to follow that flow over there, right? So Laura, is that okay? Or is there still something you're confused?
No, makes sense now. Thank
Makes
you.
sense. Okay, good. So, okay, yeah, maybe later on can think about it and then get back to me. Think about runtime, think about expectation, and then how you can combine them together. So this is one way, right? So given an invalid design, what will be the consequence if you still try to apply the rule of checking at the runtime? It's going to be equivalent to, for example, in the case of precondition, the parent's precondition is what matters. Okay, that's my point. All right, good. All right, guys, any follow-up question to Nora's question about subcontracting, or you can just ask me more about other things. Okay. Let me just open a new page. So up to now, we have learned about quite many design patterns, right? We learned about, let's think about the design patterns we have learned so far in the course, right? Because visitor is really the last one. So before the reading week, we learned about iterator. Also, we learned about singleton. So after the reading week, I think we learned about, I think the first one was the state pattern, right? After the state pattern, actually state and template, of course, we learned them together. But you should really know that there are two separate design patterns. And then we learned about observer and also event-driven design. And then after that, we also learned composite. And then we learned about visitor. If you think about it, right, of course, these two are quite interrelated, and also these two are also close related, right? Also these two as well, right? You can think about kind of learn them in groups. So I would say later on when you study for the exam, or later on, once you graduate from the course, you want to reflect about what you really have learned in the course. So these are some checklists for you about the design pattern part. Of course, we also learned about contracts, right? Let me just ask your opinion. Usually I like to ask my students to see which pattern they might like. Two questions. Number one is, which one do you like the most? Just a personal feeling. Number two will be, which one have you found the most challenging? How about we start the first question? Just let me know. I know we got a small group today, but I just want to know for those of you who are here. So which one have you found the most challenging to learn? Which design pattern? Okay, Amir, I think that's a visitor. Sure. And anybody else who want to say? Which one have you found the most challenging? Event-driven, understandable. Event-driven, interesting. I think I'll see if that's fast possible for me. Maybe for the exam review session, I'll try to see if I can give you more example about event-driven design. We'll see. Okay, good. Interestingly, you know what? I think last term when I asked my student in fall 19, they said what they found the most challenging was an iterator. That's quite surprising to me because they found that when you actually got that architectural diagram with the iteration cursor, iterable, they found it very confusing. Iterator. Okay. So now another question. Second question. Which one have you found the most fun to learn? It's more like a personal opinion. Which one do you enjoy the most? The state pattern, interesting, sure. I like the state pattern too myself, especially about template. Okay, good. Iterator, interesting. I think event, okay, really, Robbie like event-driven design the most. That's good, yeah. And the most useful and applicable singleton. I would say, yeah, I think just because the particular lab 3 and project we're having, so singleton has been very useful. But I would say, yeah, once you dive into the workplace, it's really hard to say which one you might be using more. It really depends on the domain of your workplace. Interesting. I would say, guys, I think based on many discussions I had with you, not just for the project, but just in general about lab 3 as well, I think the template design pattern turns out to be very useful. I think some of you might might already be using it without realizing it's really a template design pattern. Especially think about just very general. It's just about a very special, just a very standard way of exploiting OO facility. So whenever you got a basically you got some inheritance hierarchy, you got some parents over here, and also you got as many child classes as you like. Let's say we got child number 1, and also child number 2, and also child number 3. Let's say, right? Let's think about how the template design pattern can be derived. Think about the story over here, right? Let's say this is the ultimate, the pink one is really the ultimate template design pattern you will run into. However, realistically, you may not be able to think about you will implement the template design pattern in the first place. It might take some evolution stage to really evolve, maybe from version 1 to version 2, some intermediate stage, for example. Somehow you find that you got one class maybe called C1, and then effective, and then you got another class called C2, and then you got another class called C3. Okay, let's say we got 3 classes over here, and then let's say I would just say R just for some routine. You found that R1 over here, R2 over here, and also R3 over here. You simply find that R1, R2, R3, for now, they kind of are being developed independently, but somehow by coincidence, they share a lot in common in their code. Share a lot in common. And also, I would say minor differences. When I say minor differences, I really meant it's more like maybe only 1 or 2 lines that are simply just different. Now, let me give you some conceptual idea. Let's say for R1 over here, you can think about everything is really the same except for these 2 lines. Okay, let me be a little bit more. I just try to be a little bit symbolic. So let's say the blue one is really the same part, and this part is really different, the pink one, right? And then let's say over here for R2, you also got the implementation over here. This part here is really the same, and then somehow we got something that's slightly different. I'll say triangle, okay? And then you just got the rest will be the same. And then for R3 over here, everything in the beginning is really the same, but now in the middle, you got something that's completely different from R1 and R2. So let's say it's square over here, okay? And then after that, like that. So basically now you realize basically this part here, and this part here. So these are the only thing that's really different between R1, R2, and R3. However, the rest, which I didn't highlight, are really identical among the 3 routines. So you're in some way, you're really having duplicates, meaning that you are violating a single choice principle. That's really crucial for you to consider. So now in this case, what should you do? I would say whenever you run into such scenario, it's a very good indication that you want to apply the template design pattern. And how? Let me just, let's take this as a quick review. In that case, what you would do is, you know that this part, okay, you know that this part is really specific to C1. This part is really specific to C2. And this part here is really specific to C3. So those parts should not be shared. So those parts should not be inherited, basically, from any common ancestor. However, this part here, they are really similar, right? They are really the same. In that case, they should be shared and factored out into a single place, okay? So now what I would do instead, let's try to see how you can do that thing symbolically. So now you want to do some refactoring. Okay, let's see how how we can do it. So basically, you are going to have, rather than R1, R2, and R3, we have a single routine called R. And then its code structure looks like this. Okay, and then we're just going to have, so this part over here, just the same, right? You can see this part over here corresponds to here and here, right? And then this part here, we are not too sure. So what we'll do is we're going to make it another defer routine. So why don't I simply say, let me just say maybe R2, if you don't mind. Just say R2 over here. And then let me just write a little bit better. Let's say R2 over here. And then R2 at the level of the parents is simply just deferred, meaning that we don't know what R2 is at this level. And then in C1, C2, and also C3, we are just going to implement them, right? And now for the R2 in C1 is going to be this. And for R2 in C2 is going to be triangle. And then for R2 and also R2. Sorry about that. This should be also R2. And the R2 that's in C3 will just be the rectangle over here. Right? Hopefully you can see that conceptual refactoring, from something from a design that violates the single choice principle into the template design pattern. That's really the rationale. Okay. All right. I think I personally really like the template design pattern a lot myself because it really exploits the real ability of OO. So if you know how to refactor your design from something like this into something like this, using the template design pattern, that means you have a true understanding of OO, at least. All right? All right, good. Anyway, so I thought just want to talk a little bit about the design pattern. I would say design pattern is definitely one important learning outcome for the course. But apart from that, we also learned about modularity. We learned about, we review inheritance, subcontracting, contracts, and many other things, right? All right. Okay, any more questions? Any more? Since everybody is okay with the visitor, I hope, right? I think the visitor design pattern, the main thing is about architecture and also the double dispatch. Just make sure you know how to, how to really trace the double dispatch, right? All right, I will wait a little bit longer just to see. Maybe I'll be expecting maybe a little bit more question maybe next week, because I think for the final topic for the course, it's about software correctness. Maybe it's more about linking software together with the logic that you learn in 1090. So possibly you have more questions next week, but I think this week is a little bit lighter than usual. And for those of you who might be wondering about the TA hours, so because next Tuesday will be the last day for the semester, so we don't have any more scheduled labs starting from next week. So this week, Wednesday, Thursday, and Friday will be your final chance to speak to any TA. So please take advantage of that. But I will still have my office hour as usual, so you can still speak to me next week.
Could I ask a question of week 6?
Go ahead. Yes.
I was reviewing the quizzes, and in one of the quizzes in week 6, I have a question about one of the questions there.
Which quiz are you talking about? Do you know which one it is?
It's quiz 6.
Quiz number 6. Okay. Just give me one moment. I can dig it out, and that can benefit everybody here. Just give me one moment. Quiz number 6, right? Okay.
Yeah.
Give me one moment. Okay, let me go to eClass, and then if you say quiz number 6, okay, let me just go there. And then if I go to quiz number 6, moment. Okay, let me just move things around over here. And then let me go to the quiz. Do you remember which question it was?
It was question 3 in my.
Can you tell me what the question was about? It's about precursor?
It was about if it satisfies cohesion and design single choice.
Okay, it's quiz number 6, you're sure, right?
Yes,
okay.
Quiz number 6.
Oh, could be this one here, could be, okay. Is it this one?
Yes.
Okay, let's take a look. Yeah, let's take a look. Which one specifically do you have question?
Yeah, my question about the cohesion part. I still don't understand why this doesn't satisfy
Oh, okay,
cohesion.
no problem. Sure, no problem. Let's talk about it. It's also very important. Yes. I think this is just another example where you might not be really making use of the OO ability, to the full extent. So let me talk about it. Good. Okay, very good. Okay, I think this one here is kind of assuming that you already studied the first. Let me just give you one connection over here, and then I'll talk about this one specifically. So if you go to, for example, our lecture notes, let me just point it to you. Blackboard. Yeah, give me a moment. Let me find it out. It should be around the inheritance. Okay, let me find it. Should be around here. Okay, good. Over here, basically. So let's just review this very quickly, and then we'll go back to that quiz question. You can see that over here, we talk about in the inheritance lecture, in order for you to distinguish between resident students and non-resident students, one way to do it is simply to say we got only one class called students over here. And then the way to distinguish between that is simply got an integer variable here. In theory, you got 2 to the 32 possibility, right? So that's definitely more than enough. Of course, you can also say simply just a Boolean. If you simply just got either true or false, meaning that you got only 2 kinds of student, that's also fine. Okay, but just make it more general, we'll just say integer. So what this means is, whenever you want to create a student instance, you're going to put the kind number over here, either 1 or 2. So the assumption we're making here, for example, is 1 will be the resident students, and 2 will be the non-resident students, like that. And then you're just going to assign the kind over here. I can say make kind number 1. In that case, I'm creating a new instance of resident students. Or I can say kind number 2, in which case I'm making the other kind. All right. And then let's talk about this over here. So what's going to happen here is, in the same class, you actually got the various attributes. And this particular attribute, premium rates, is applicable to resident students. And this attribute here is applicable to non-resident students, right? So now, at the runtime, what's going to happen is, let me just go back here, okay? Let me go back to here. At the runtime, if you think about what's going to happen here, if I simply draw 2 student object here, if I simply got students objects over here, let's say S1, okay? And also I got S2 students. And then, of course, every student's objects got at least 3 attributes. If you just recall, we got, let's not worry about the courses. It's really common for both of them. That's fine. Let's talk about kind, premium rate, and discount rate. Okay, talk about these 3. So what we're going to get is, let's say we got the kind. Okay, also we got the kind over here. Let's say the first one is simply just 1, which means we're talking about our resident students. And the second one is simply 2. We're talking about non-resident students. And then we got premium rates, we got discount rate, we got premium rates, and we got discount rate, right? So cohesion is really violated because in the case of resident students, the discount rate is not cohesive. In the case of non-resident students, in that case, premium rates is actually not cohesive. It's not applicable. So Nora, do you follow so far?
Yes.
Okay, good. So that is why if you simply use just some extra attribute or like a flag to really distinguish between the kinds of objects, either resident student or non-resident students, you are definitely going to run into issues about cohesion, because in the same class, you have to include a union of all the features applicable to either kind number 1 or kind number 2. You can think about this as the union. However, part of it may just not be applicable when you have a particular kind of students, and similar here. So when you have kind number 2, this is not applicable, right? Okay, let me just draw a little bit closer connection to your project, for example, right? So let's say you got so many enemies. Let's say you got 5 or 6 kind of enemies from your projects. I remember maybe I saw one of your fellow students when they showed their design to me. I also gave them the similar comments. The way they actually distinguish between different enemies is by creating a class called enemy, and then, okay, enemy, and then they simply just put kind, similar to that, but they don't really call kind, but something similar. Kind maybe just of an integer, or simply like a character, or maybe it's character. The kind is simply a character. So class enemy, and then kind would just be a character. For example, it's going to be maybe C for carrier, F for fighter, and also P for pylon, and etc. So you can think about this design here will actually suffer possibly from the same outcome, the same design flaw as you see over here, because there might be something that's very specific to carrier. There's something very specific to fighter, but you will put all of them into the same class. So that was actually violates cohesion. So Nora, so far so good?
Yes.
Okay,
Yes.
very good. Let's now talk about your quiz question specifically, okay? So here, you can think about what we're having is we're having a single account class over here. But we actually set, so here, this is the flag over here. So it's savings. Think about what's going to happen at the runtime. And notice that we simply say other commands are omitted, right? So whenever we say you want to consider a particular design, so you don't necessarily just consider whatever that's given to you. Whatever given to you might be suggesting if you want to add anything new to the design for extension, then you will suffer from cohesion issue, okay? So let's say this. For example, over here, we simply got account. And then very similar scenario over here. And also we got account. The same. Okay, let's say ACC1 and also ACC2 over here. Let's say over here we still got 3, and the one I already showed to you in the quiz question was is savings. Is savings. Let's say the first one there is simply just true. So that means this is a savings account. And the second one here is simply false. So that means it's a checking account. All right, so we got 2 different account objects over here. Even though I don't really show you anything over here, but I simply say something are actually omitted. So I would say whenever you actually see you're trying to distinguish between instance types using some flag, that's already suggesting that in the future, if you're doing some realistic design for this module here, you will definitely run into the cohesion problem, because you're trying to put all the union for all the features that's relevant to either savings or checking into the same class. So definitely they don't belong to each other. So you would just suffer from the same disadvantage like this. Just give you one example. Let's say for savings and checking, they might just have maybe different charge rate. For example, whenever you want to deposit from your checking account, they might charge you something with the rate, right? So I'll just say maybe for savings rate, and also with a checkings rate, right? Just some special rate that should be applied whenever you want to withdraw some money from a particular account. And also here you got savings rate, and also you got checkings rate. So now let's think about what's going to be not cohesive. For example, in this case, when we talk about savings account, apparently checkings rate will not be cohesive, right? It's not consistent. And also when you talk about checking account and the savings rate will not be compatible, right? So that's how it would violate the cohesion principle.
Okay, I was just confused because it says other commands omitted, so I thought by commands they don't mean
also,
attributes.
still similar. So for example, what I'm omitting over here, for example, it could be potentially, well, attribute is just one example. It could be maybe I would say withdraw from savings. That could be one. And we got another one maybe withdraw from checking. Right? So these two apparently are different commands, but you're putting it in the same class. And this one is only applicable to this object over here. And this one is only applicable to this object here. So you're still violating cohesion. Command will be another example.
Makes sense. Okay, thank you.
Okay, no problem.
Yeah.
All right. Guys, any more questions? Any more? Or any general design question you may have, you can feel free. I'll try my best to answer. Otherwise, I can do a little bit of research offline and then come back to you. Okay, any question you want to ask. Okay, I'll wait a little bit, just for you to think about if you got any questions. I think your exam is. I know that you got your phase number 2 due next Tuesday. Sorry, Wednesday. I don't want to scare you. It's next Wednesday, December 9th. It's really the last day for the university. University say the student can turn in their work for grading. So Wednesday is really the furthest I can push. And then after Wednesday, I understand that you got other exam as well for your other courses. But for our exam, it will be December 20th. I will give you guys more information about the exam maybe after you submit your phase number 2. So for now, you don't have to worry. But you may want to plan ahead your time if at all possible. Maybe start reviewing your notes already because the exam will be comprehensive, meaning that everything that we cover in the course may be covered, right? So you may want to start thinking about it. Oh, let's see. One question from Robbie. Question about the composite design pattern. Why would we want to make the composite class iterable? Okay, and then isn't it already iterable? Because the children is the only attributes and it's a list which is already iterable. Okay, that's a good question. I think Robbie maybe is a response to the optional exercise I put on the slide, saying that you may want to do an exercise by making the composite iterable. So let me put it this way here, Robbie. Okay. Think about the two alternative scenario. Either we make it iterable or we don't make it iterable, right? Either way. Let me draw some diagram over here. So let me still use the equipments example here. Okay. So we got our equipments, and then under which we have, let me just say card over here, just one, just for example, and then under which we actually got the composite equipments. Composite equipments, and because of multiple inheritance, we also got the composite over here. And that one is generic, of course, right? And we know that from the lecture, this one here is going to be composite equipments inherits composite instantiating T to be equipments, right? That's something I don't have to bother you anymore, but that's something you know. And then let me just put one subclass over here, just one. And then this one over here, let's say chassis. All right, so that's kind of the composite design pattern you have, right? So this one here works. However, let me be more precise about how it works. Let's be a little bit more, let me add a little bit more information here. So remember in the composite over here, we actually got children, which is, let's say, a list of T. And then we also got add child, and potentially you can also have run command called remove child if you wish, right? Just the various commands for modifying the list. Okay, I'll leave that to you. I'll let you just for children. So now think about it on the client side. How do I, apparently children will be inherited to the composite equipments, meaning that if I got a code like this, for example, if I say C of type chassis, and then I simply do a little bit of manipulation here. I simply initialize the chassis C, and also let's say I add the various equipments into it. Let's say I have done that already, right? Add the various equipments into it. Right? For that, you know how to write a code. Let's say now, I would like to go over the children of this particular chassis C, one by one. How would I write it? Robbie made a very good, very correct observation that children is already iterable. But how would I write it? I would say across C dot children is, okay, and then every one of them is going to be, well, T has been instantiated using equipments already, right? Is equipments. And then I can have a loop over here, and then I can do something. With the equipments over here, right? And this is really of type equipments. All right, so far so good. This is something that Robbie is definitely very comfortable with. So he might think it wouldn't be so necessary to really make the composite class iterable because we can already use a cross loop on C.children. I would say if you can make your client's code easier, you should really try. Meaning that if we don't really have to write something.children, wouldn't that be nicer? Wouldn't that be easier? That's why I give you that exercise. Let me show you what I meant. So what I would do is I'm just going to copy this part of the diagram, or the entire part. And let's see what's going to happen here. Okay, let me just make it a little bit smaller. Okay, that's going to be the second design. Okay, just a different color here. Okay, so this is the alternative design. And then for this part, let me just make sure I don't confuse you with the color. So now let me just put it back to the normal blue. Okay, so you can see these two are just related, right? And then let's say for this one here, I'm just going to first, again. Okay, so now how can we make the composite iterable, right? You learned about how to, the iterated pattern. Let's just talk about briefly about how you can do it. Basically, you will have to make sure this class over here is going to inherit from iterable. Typically, whenever you try to draw inheritance, it should be vertical from down to up. But for now, I'm just running out of space, so just bear with me. I'll say over here, and then so this should be iterable, basically. Okay, and then we know that once you make it iterable, you have to define a new cursor. Right? So this is something you will have to implement for the composite, right? You can definitely do that on your own. You will know how to do it. You simply did lab number 2 related to this. Let's say we follow this particular design. So now, what's going to be the convenience, the more convenience that can be gained for the clients, right? Let's think about it. If I get C of type chassis over here, okay, and then we do whatever is necessary, just about initializing and also adding the various components to it. So now, in order to, you can think about chassis over here is really a subclass of composite equipments, which is a subclass of composite, which is also a subclass of iterable, right? You can think about chassis is really a descendant class of iterable, meaning that we can use the chassis object itself directly for the targets for the across. That would be easier for the client to write. So let's try it. So you would say across over here. So now rather than saying C.children as we did before, you can say across C is simply equipments. And then you still got your loop and also you got your end over here, right? And then you can do something with the equip. So this, you can see, even though the difference is very subtle, it's very like a C versus C.children. However, you can think about it's like if you have to go do the cross loop on the various components under composite equipments many times, very often. In that case, saving .children for every such line will be quite a big thing to actually have, right? So I would say that's actually quite a good improvement to your design. So we are really improving from having to write see the children over here as the target for the across to just see. So that's an improvement. So Robbie, does it make sense to you? Yes, right? Okay, good. Okay, so now you can think about going from here to over here. You can think about we try to it's improvement. On the design. Because simpler. For the clients. All right, good. Yeah, Robbie, that's a good question. Good. All right, guys, any more? Any more questions? I like it. Actually, today we didn't talk about visitor at all, but we talked about many good things, actually, apart from a visitor. That's nice. All right, any more? I can take more if you wish. Okay, I'll wait a little bit longer. I think such questions about, hopefully in the exam review session, given that you already study individual lecture for your weekly quizzes, so I think you want to really come up with the question that's really going to be involving multiple lectures. For example, you may want to ask me about how, maybe for example, how the composite design pattern is related to visitor, right? And also how the observer pattern should be used for the distributed system, as I first explained in the lecture. So those questions can also help you having deeper knowledge about what we cover in the course. So that's so studying for the exam that's comprehensive really give you an opportunity to think about everything at one go, put them together, right? Do we have quiz for week number 12 as well? Yes, we do. We do. So if you look at the course calendar, we do. Right? It's going to be due next Friday. In case you have doubts, let me show it to you. Of course, you're more than welcome to actually complete your quiz number 12 earlier if you wish. So we want to make sure we give you, always we give you 1 week to complete your quiz. Let me show you this diagram over here. So remember this diagram we went over in the very beginning of the semester. You can think about we are now here. Yes, we are now here, basically. December 1st, sorry, we are here, okay, December 1st. We are now here, and then officially your week number 12 lecture will start tomorrow, December 2nd. And then next week, Monday and Tuesday, we'll talk about your week number 12 to see if you got any questions in order to take your quiz number 12. And then I know that December 9th, you might still be busy with your project. That's okay. Even if I would suggest maybe study a little bit for your week number 12 lecture so they can ask me some questions just to clarify for 7 and 8. And then after December 9th, you can still take the Thursday or have a Friday to really get do some final minute study and then to really take the quiz. Okay, that would be my advice. But yes, you do have a quiz number 12. Yes, you do. All right. Okay, another question for Nora. Can I elaborate on the final exam? How is it going to be? Yes, and also multiple choice questions, short answers. Is it going to be on Moodle like the quiz, open book? I don't have the exact final details yet, but I can tell you a few points that's really for sure. Number one, your exam is going to be on E-class, number one. Number two, you definitely will get multiple choice question for sure. However, how many short answer question you might have, I don't have an answer yet. I think once we get to the review exam session, maybe the first one or the second one, I will be able to tell you whether you should really expect some short answer question. Okay, for now, I don't know yet. And it will be open book. Yes, it will be. I don't know yet, but your exam is scheduled to be 3 hours. I'm thinking that we don't necessarily have to use all the 3 hours. It could be that we can make it just like a 2 hours. But of course, I'll make sure the questions are still reasonable for 2 hours. I wouldn't give you like a 3-hour exam, but only give you 2 hours. It's not my intention, right? So we can simply just make it a little bit shorter for everybody. But there's something I'm still considering. I don't know yet. Also, it depends on how many TA hours I will get remaining for to help me grading. So that would be my concern as well. But that's not your problem. Don't worry. And then I think for now, if you do want to start studying for the exam, your best bet would be to focus more on the confusion or concept that might involve multiple lectures. You really want to put everything together, right? And of course, I would say everything may be tested on what we have covered. So you don't necessarily have to think that whatever we cover after the reading week will be put more emphasis, not necessarily. Because I think that since we are running this course online this semester, so we basically have got some very steady assessment on your weekly lectures. So I would say everything is really important. So you want to study everything. So you may want to start reviewing your lectures. Okay. Okay, from Lenore, would the exam be open for the whole day? But once we start the exam, it will be to have 2 hours. Yeah, I think Lenore, that would be like a technical question. I will try to confirm with you guys maybe a little bit later. Okay, I don't want to say anything for sure now. I will definitely confirm early enough. Okay, or will our exam strictly start at 9 a.m. on December 20th? I think since the registrar office actually scheduled our exam to be 9 a.m. to 12 noon EST. So I think officially that's something we should follow. However, if there's any flexibility I can add, I will still need to consider. No promise now, so I'm thinking about it. So no final answer yet. But you can think about, it's very likely we might just go with maybe starting from 9 a.m. And then I'll give you, you can say, you should really, I'll just give you one example. It's not really for sure, just one example. It could be that between 9 a.m. and 12 noon, the exam will be open. The exam will be open during that period. You can choose to start anytime for 2 hours between 9 and 12. That's one example. But exactly how that's going to happen, I'll let you know. Okay. Well, we have to draw a bound diagram in the exam. That's a good question. For now, I cannot think of a good way for you to really upload your diagram and then to get it graded. I don't want to say no for now. I can just say it's unlikely. However, the fact that you don't really have to draw a bound diagram, you might be given bound diagram to read, right? But whether you want to draw it or not, I don't know yet. I will confirm with you also maybe a little bit later after the semester ends. I'll make sure everything will be finalized at least 1 week before the exam, so you know exactly what to expect. Okay? Because I think if you want to, if I ask you to draw a bound diagram, the problem is I cannot assume everybody will be so smooth about maybe taking a picture of the diagram and then upload it to your e-class. In that case, you know, I might just get lots of hassle there for myself. So I don't know yet. I'll think about it. Okay, when will you have the final grade for this course? Okay, I would say this is tricky. So guys, think it this way. Think about in my situation, you guys will finish the exam about December 20th, right? And then it will since that we got about more than 300 people in the course. So for me to gather all the TAs and also to get to really grade whatever short answer or textual answer question we might have, you can easily extend into the 24th or even the 25th, which is already the holiday period. So I would say, yeah, I don't know yet. I'll think about it. So hopefully I can submit your grade to the registrar office maybe hopefully by the end of the year, I'm hoping. And once it's submitted, if you got any concern, I think you would just have to follow the formal procedure if you want to look at your exam or if you want to have any part to be regraded. But I will try to make sure everything except for your exam marks will be available to you. So and you got enough chance to really submit regrading requests if needed, especially for your projects, especially. Yeah, I'll make sure that can be done. But about your exam score, I can make it available, but we may not have time for you to really look at your exam and then to really submit for regrading requests. That's not typically the case for any course anyway. I'm just trying to tell you that the time frame is really quite tight for us, right? So Amir, can you about the project design document? Yes, the project design document and your phase number 2 software are basically due on at the same time. So when you submit your phase 2, you'll just make sure your design document is in the docs folder and submit it together, basically, right? And the submission folder has been opened again, so you can start submitting if you wish. No problem, okay? And from Asma, can the exam question be related to the project, or will they be similar to example in our slides? The latter. I don't think it will be, let me put it this way. I would ask you, for example, in the quiz, in the exam, enumerate all the types of enemy in your project. I don't think that's really intelligent, question to ask. I would say maybe we wouldn't ask any question directly related to your labs or the projects, but any design principle that you're expected to learn. For example, let's say for lab number 3, I wouldn't ask you about the Space Defender 1 game per se. I wouldn't do that. However, because that requires some memorization, which I don't want you to do. However, I might ask you a question related to the undo redo design pattern, if you see what I mean, right? So I would say when you review your notes for the exam, you definitely want to focus more on the lecture materials first, and then if you got time, if your time permitted, you may just want to review very quickly about, for example, for lab number 1, lab number 2. You don't need to worry about how to implement rotation for splay tree. You don't have to worry about how to, for example, how to implement like a display operation. You don't need to review that. That one's not necessary. But on the other hand, you may want to review in the solution for lab 2 the various contracts, how we write it. So you might be asked to write some code or some contracts. It's a textual question in the exam. Once I get more information, once I finalize my question in the exam, I'll definitely let you know. Okay. Yeah. So basically, as much as it's a long response to your question, but basically, you want to focus more on the slides and also the notes. Okay. Okay. So let's see this. So Asma, you say, just curious about if you may be asked to apply a design pattern to the project or make it efficient. Maybe not about the entire project per se. So maybe, for example, I might just give you a brand new problem about design, and then I will ask you about, given this particular problem, which design pattern would be applicable to use, for example, right? And yeah, anything is possible. Yeah, anything is possible. I can definitely give you a little bit more ideas. So once we get to the exam review session, I'll try to give you more ideas. Okay. All right, no problem. So guys, any more questions? Any more? Yeah, I would give you a little bit of suggestion here. Sometimes students also find the final topic about program verification also quite challenging, simply because it's not something you have really seen before, especially linking between logic and also software, like about coding. To link this together, it does require some time to digest. If at all possible, you can manage your time. I would suggest try to maybe watch one video clip at a time. It's about 20 to 30 minutes, one at a time, and try to give some break in between so you can really have time to digest about the materials, rather than trying to watch all the 3 hours at one go. It may not be the most effective way for you to learn about the final topic. That's my suggestion. All right. Okay, guys, any more questions? All right. If you haven't really expressed your availability for the exam review sessions, please just follow the link I sent out yesterday, just to indicate which time might be better for you. I'll try to send a reminder to your fellow students maybe later this afternoon. And then once I get enough number of responses, I will finalize the exam review session, so you can also plan your other coursework accordingly. Okay, I'll try to do that hopefully by Thursday or Friday. Okay. All right, is everybody okay? All right. All right. If everybody's okay, so I will call it a day. And then, yeah, thank you for coming. And then good luck to your quiz number 11. And then I would say, yeah, so maybe start planning how to study your exam. Of course, you want to complete your project as well. I cannot emphasize enough, you will need to write as many acceptance tests yourself as possible to cover many other scenarios in order to receive a grade that you will expect. That's my best advice to you. Right, but if you got any trouble, I still got office hour today and also tomorrow, and also next week as usual, Monday, Tuesday, and Wednesday. All right. So guys, I'm gonna stop the recording right now, and then I'll see you maybe later in the office hour or maybe next week. All right. Take care. I'll see you later. Bye bye.